In the previous video, we explored QML's syntax and the 4 building blocks. Now let's dive deeper into the first building block, properties. We'll learn about different data types, how to define custom properties, and important concepts like property aliases and grouped properties. Here's an example of an image object with its source property assigned to a local URL. It has a child text object whose text property is assigned a string value. The text is positioned in the center of the image using anchors. We should note here that all QML properties have specific data types associated with them. The type of a property determines what data the property can hold, and what operations can be performed on that data. You can define your own properties for any QML element using the property keyword, followed by the property's type and name. This allows for greater customization and extensibility of QML components. Here, we define a custom property, name, with type string and property, age, with type int. When defining custom properties in QML, it's important to note that the property name must start with a lowercase letter and can only contain letters, numbers, and underscores. There are simple value types, such as int, double, string, and bool, as well as structured value types, such as rect and font. In addition, there are object types for declaring elements. As mentioned before, they have uppercase names. You can also use them as property types. Besides those, there are sequence types and enumerations. For every object type and value type, a sequence type for storing multiple instances of the type is automatically made available. You can use the list keyword to create properties of sequence types. An enum enables a variable to be a set of predefined values. The variable must be equal to one of the values that have been predefined for it. The enum and its values must start with a capital letter, and a value can be stored with the int or double type. Enumerations are not separate types in QML but are properties of their surrounding types. We can see this in the example, where we have created an enum in main.qml and initialized the selected pet property. QML also supports type inference by its var keyword, which means that the data type of a property can be automatically inferred from its initial value. For example, if you assign a string value to a property, QML will automatically infer that the property is of type string. The var type can be used as a generic property type that can refer to any data type. It is equivalent to a regular JavaScript variable. Var properties can store numbers, strings, objects, arrays, and functions. It is worth noting that using var allows you to assign values of different types to the same property at runtime without the QML engine reporting an error. This offers flexibility but sacrifices type safety, making the code harder to debug and potentially less performant. Strong typing is a best practice in QML as it prevents the assignment of wrong values, makes code easier to read, and allows for better tooling and performance optimization. When a value with an incorrect type is assigned to a strongly typed property, the QML engine will issue an error in the console, pointing to the exact line where the type mismatch occurred, which greatly aids debugging. In this example, we see an error because we're trying to assign a string value to a property that expects a numeric value. As a result, the QML engine will not load the object. It's important to ensure that correct types are used when assigning values to properties to avoid errors like this. There are 2 main types of data in QML: value types and object types. Value types have lowercase names and are passed by value. If you assign the same value type to 2 properties, they carry separate values. Modifying one doesn't affect the other. Object types have uppercase names and are passed by reference. If you assign an object type to 2 different properties, both properties carry the same value. Modifying the object is reflected in both properties. Let me show you an example. Here we have cat and dog properties with type string. Both are bound to the same property name. Because string is passed by value, modifying the dog property will not change the cat property or the original name property. However, if you assign an instance of an object type to a property of the same type, both properties carry the same value. In this example, the property, cat, with a Qt object type is defined. Modifying the value in cat also modifies the original object because it's passed by reference. Property aliases are properties which hold the reference to another property. Unlike an ordinary property definition, property aliases do not allocate new unique storage. A property alias connects the newly declared property as a direct reference to an existing property. An alias declaration looks like an ordinary property definition, except it uses the alias keyword instead of a property type. The alias reference is not optional. Unlike the optional default value for an ordinary property, the alias reference must be provided when the alias is first declared. It cannot contain arbitrary JavaScript expressions. You can forward a property to an outer scope with a property alias. This is particularly useful when you want to create a reusable component and design its public-facing interface. In this example, we forward the text property of the text object to the component scope. Also, the width and height properties of the inner rectangle are forwarded to the root item. For properties with an inner structure, you can use a logical group of subproperty attributes to populate them. These are called group properties. There are two ways to write group properties. You can use the dot notation or the group notation. For example, the text object has a predefined property, font, of the value type font. Font has several properties like pixel size, family, italic, bold, etc. Since font is a value type, you cannot create an element for it. To populate its properties declaratively, you can use group properties. Declaring a property implicitly creates a value change signal for that property. You can handle the change signal using an associated signal handler. In this example, we want to handle the change in width by implementing an onWidthChanged handler. When a change in width occurs, the widthChanged signal is emitted, and it is handled in onWidthChanged. Similarly, the nameChanged signal is emitted when the value of the name property is changed. The onNameChanged signal handler is where you implement the response. These signals are written in the form onPropertyChanged, where property is the name of the property, with the first letter capitalized. Now that we understand properties and types, we're ready to explore one of QML's most powerful features, property bindings. In the next video, we'll learn how to create dynamic relationships between properties that automatically update when values change.